Well, hi, this is Geoff Horne, all the way down here in the bottom end of the planet, Wanganui, New Zealand. And yes, you'll probably figure that my voice sounds a little bit different to most of you. But in this wonderful virtual Zoom world of ours, we have this marvelous technology that enables us to communicate across the globe. So thank goodness for Zoom. Today, the good folks at Inflectra have allowed me to demonstrate a tool that I developed over the last sort of 15 odd years, just by way of a bit of background. I have been a test manager for 25 years now, mainly specializing in implementation projects as opposed to development. So implementing ERP products like SAP, JDE, Technology One, large mission critical applications that really have to be implemented in the appropriate manner. And of course, my job has been designing strategies and coming up with estimates and running test programs and teams across the implementation life cycle. One of the things I have always found difficult with testing is that a program director or a manager somewhere comes along and says, "Hey, Geoff, how long is this all going to take and how many people do you need?" Now, over a period of time, nearly all test managers would tell you that we can kind of develop a bit of a nose for these things. But nothing is better than having something hard and fast with a little bit of science behind it to give a bit of weight to a test estimate. So the tool I'm going to show you today is I've called affectionately the testimation for obvious reasons. And it's a tool that it's spreadsheet based, so it's all Excel, but it's a tool that basically tries to put some sort of quantification upon a test project before you actually start doing your testing. And basically it works by entering a base set of parameters, then a set of variable parameters, and coming up with a series of metrics, or indicators, I should say, rather than metrics. And they're not so much designed to provide a hard and fast, guaranteed estimate. It's really just coming up with a few buckets to say, hey, this is the bucket of time we think we need. This is how many buckets of people we think we might need and for how long. And really just to put something down on paper to be able to go to a steering committee or a program director and say, look, this is the science behind it. This is the estimate we've come up with. Now, I know the first thing that a lot of you are going to say in this day and age is, well, those great big monolithic programs don't really exist anymore because we have this marvelous new technology or methodology called Agile and all its derivatives. And there was probably some argument to be had for that as well, in as much that a lot of test efforts are now split into short-term sprints as opposed to big monolithic projects. However, there are still implementation projects where the agile process is not always the best option to take. Now, I know agile diehard enthusiasts will disagree with me, and that's fine. I guess from my experience, I have come across a number of projects that have attempted to use an agile methodology to implement an off-the-shelf software system, and unfortunately hasn't worked particularly well. So I guess part of me wanting to demonstrate this product is really just to get a bit of a feel to see whether folks think that there might still be some mileage in a tool like this. Now, as I say, it is a spreadsheet base, so there's not a lot of development technology behind it. There are some pretty complex formulas in there that I've struggled over the years to make sure I get right, but I think I'm pretty close. So without further ado, I'm going to jump into the share screen mode, and I'm going to show you the testimation tool. Please bear in mind it is just a spreadsheet tool. It's not supposed to be a be-all and end-all. It's just supposed to come up with a few indicators of how long a test project might take and how many people it might take to do it. So as we go through, I'll explain each section of the spreadsheet, what it's designed to do. the different parameters and the results that we get out of the end of it. And as I say, the intention is not to try and sell a tool because it is just a spreadsheet. The intention is to try and gauge and understand whether there is still felt out there in the testing space a need for such a tool. Anyway, here we go. If I get this right. Right, so here we are. I hope you can all see this, and it's clear as day for you. So this is my testimation spreadsheet. As you can see, I've tried to make it as user-friendly as I can. So the first part of the spreadsheet is that it's just we identify our project, or the stream, or the effort that we're wanting to provide an estimate for. Now, this could be as simple as a short-term sprint within an agile world, or it could be as large as a multi-month monolithic implementation test period. So we identify our test period, the type of testing that we're undertaking, a date we produce it, and who it's by. And it's really just simple notational stuff. In the details section here, we have the ability to be able to enter a number of business requirements. The way it works is that we have business requirements which are broken down into test requirements, which are then broken down into test cases. So if we have 100 odd business requirements with an average of a couple of test requirements per business requirement, and say an average of 3 test cases per test requirement. Now, this raises an interesting point even right early at this time, is that no testing effort is uniform. Okay, I fully understand and know full well that some business requirements are very simple, some business requirements are very complex. Some test requirements are very simple, some are very complex. Some test cases are very short and straightforward, others are very, very complex. And often it's the ones that you think might be simple are also the ones that take you the most time. But again, this is really just to quantify something to put a stake in the ground to work from. We can specify the number of test cycles we might be going to run. So normally we have a full-blown first test cycle, and then we will have a number of regression test cycles. Bear in mind that each regression cycle may be a full repeat of the initial test cycle, or it may be a cut-down portion of it. We can specify in here any number of days between test cycles to allow for. We can specify a number of test analysts. We can specify a start date, and in there, if we have any non-working days, e.g. public holidays, etc., we can specify those too. So that's really just a bit of basic background to enter into the tool. Then we have what I call our control panel. And in here, we can put some estimates in around our productivity. So we may estimate that in this first phase of this project, we're going to have around about a 25% failure rate on test cases. Now, the reason that we're quantifying it like this is to try and estimate how many defects we might come up with. And yes, I know there's going to be different severities and priorities, and we'll get onto that in a moment. We also specify how many defects we can remove per day. By this, what I mean is on average, on each day that we are testing, how many defects can we actually close? Now, this assumes, of course, that defects go through their normal investigation cycle, their normal repair cycle, their normal retest cycle, any regression testing around it. And over a period of time, any test manager will tell you that a picture starts to form of how many defects you can close on a daily basis. Again, it's not uniform. It's just a stake in the ground to estimate from. We can then enter the amount of time that we want to estimate for designing a test case by requirement, the average amount of time it might take to develop a test case. It doesn't matter whether it's manual or automated. Again, we can put an estimate in there of time. How long it might take to set up, in other words, get all your test data in order, create any test data that you might need. How long it might take to execute each test case. Again, bearing in mind they're not uniform. Some will be long, some will be short. Any execution overhead, in other words, time to log defects, time to write up reports, etc. An extra overhead for allowing any rework between test cycles. As you're probably well aware that you run through a test cycle and you find new test cases that you need to add to the next regression cycle. Here on this parameter here, the retest per cycle parameter, how much of each test cycle are you going to repeat in each regression cycle? Are you going to do the whole lot, or are you going to just run a portion of it? Any tester, lead or manager will tell you that we might be sitting at our desk for 8 hours a day, but there are always meetings, interruptions, lunch breaks, toilet breaks, etc. So we very rarely get 8 hours productivity time. I usually use 6.5 hours a day as a starting point. The number of working days per week, normally this is going to be 5. But in some cases, it might not be. You may choose to work Saturdays because you've got a tight timeline. You may choose to work less than 5 for whatever reason. The standard hours in a working day, this is not productivity. This is the number of hours that you're paying your people for. Normally, it's going to be 8 hours or 7.5 in some environments. But this is to help with the costing estimates. Always, when you have multiple team members working together, there's cross-pollination of ideas, there's chats, there's peer reviews, there's all sorts of things that comes with having larger teams. So with this parameter, we can allow a diminishing return. So if you have a team of 10 testers, you might not get a full 100% effort from them all day, every day, because of cross-pollination of ideas and etc. So you can put a small overhead in here. You're always going to have sick days, people off sick, people taking time out because of dentists and doctors, etc. So with this parameter, you can estimate the amount of time that testers will be actually on the job and working. You also have the ability to add just a general contingency factor. I always start with 20%, maybe a little more. Of course, a good program manager is always going to come back and trim that down for me, so I tend to estimate on the higher side. To help with cost estimates, I can specify here the amount of money that we're going to pay per test analyst. Obviously, if you're employing contractors, then it's going to be fairly straightforward. If you're working with full-time employees, then you might have to make some allowances in there to express this as an hourly rate. The same with your management overhead, and the same with any other overheads you may have. You may have costs to hire equipment, to rent office space, etc. So with the details and our control panel, we have the basis of the project that we're going to estimate against. Sorry, that was my phone just going off. Just excuse that. Just 1 minute. Hey, love, I'm just on a conference call. Can I call you back? Yes. Oh, okay. All right. I'll call you back very shortly. Okay. Bye-bye. Sorry about that, but I'm not going to go back and start again. Anyway, back to our spreadsheet, our adjustments. Now, we have 10 test analysts for this project we see down here. Not all test analysts are going to be at the same level. Some of them are going to be juniors, some are going to be seniors. So in this section here, you can add a productivity increase or a productivity decrease depending on the level of your test analysts. Complexity of your requirements, as I mentioned earlier on, they're not always going to be 100% uniform. So in here, you can add an overhead for more complex requirements and reduce it for lower complexity requirements. The test cases that you produce are not always going to be as important as one another. There are going to be some that you absolutely have to test. And at the other end of the scale is some where you actually won't test, so simply because the benefit of doing so is really not there. So again, you can specify the breakdown of your priority and exactly which test cases you are going to execute. In this case, we can see here, we've basically said we're going to execute all priority 1 and 2 test cases, but we're not going to do anything else. And we'll see what effect that has on things when we come to use the tool. We can also allocate a severity against our incidents, because as we all know, you're not going to fix every single incident before you go live. Your lower priority and lower severity issues, you're probably not going to look at. If you can go live with them and it's not going to affect productivity or impact your business in a severely adverse way, then you may choose to go live. So again, here you can specify the breakdown of what your expected severity of incidents is and what you're going to fix. In this case, we're fixing severity 1s and all severity 2s. So applying our details, our control panel, and our adjustments, we then come up with our estimates. So in this case, we have 100 odd business requirements with 2 requirements per business requirements for testing and 3 test cases, which equates in this instance around about 200 test requirements and around 600 test cases. Based on our control parameter input over here with timing allowances, that works out to be roughly 120 hours design time, 360 odd hours to write your test scripts. Your first cycle of execution should take you 530 odd hours, and your 2 regression cycles 700 something odd hours. So give you a total hours breakdown of 1700. If you then work that out in elapsed time, applying the fact that you have 10 test analysts broken down by this productivity, it translates into, at the bottom line, around about 2 months worth of testing with 10 people. Based on a 31st of August start date, that means that you'll meet your completion criteria around early November by your incident severity fix and your test case priority execute, and around about the 7th to do everything. Your cost estimates based on the parameters down here and your hourly estimations up here provides you with a ballpark figure. Even though I know it looks exact, it's really just a ballpark figure based on the number of test analysts that you've got and the config that you've got. Obviously, your productivity and your contingency factors come into that as well. Now, at the very bottom, we actually try and attempt to estimate what would be the optimum number of test analysts to get this job done in the shortest time possible. Now, that takes into consideration a few things. And if you have a look down here, we can see that our incident fix time and our execution times are actually quite different. So it's in this particular project with these parameters, it means that our time for actual testing is going to take longer than it's going to take for our incidents to fix. Now that's good, but it also means if we had more test analysts, we could actually execute it faster. So I'm going to just make a very small change. I'm going to increase the number of test analysts, and we're going to see what effect that might have on these estimates down here. So if I go in and increase that number of TAs to 15, and I will increase our number of intermediate test analysts accordingly, and we can see fairly clearly that our estimate of time for actual test execution has come down. Our incident fix time doesn't change because we haven't increased our defect stats and fixed them any faster. If we then wanted to go through and say, let's say we only can fix half the number of defects per day, then we'll see that automatically our incident time has come up. Our execution time remains the same, but because we're going to take longer to fix our defects, there's no point in having 15 test analysts on it because a lot of the time they're going to be sitting around twiddling their thumbs waiting for defects to be fixed. So you can see down here that our optimum number of test analysts has dropped down to 9. Now, we can also fiddle around with some of our other parameters. Let's say, for instance, that our amount of time for developing and writing out test cases is doubled. We can then see what effect that has on our execution time. It has increased it a little bit. Our incident fix doesn't change. Let's see what happens if we upskill our test analysts. So let's make our number of senior test analysts the full 15. Now you will note that if I change a figure here and it doesn't correlate with my number of test analysts, I do get an error. And the tool will flag where your numbers aren't adding up and preventing it from providing you with a proper calculation. And as you can see, our amount of time for testing has actually gone down. And all of a sudden, we're actually finishing around late October. So we can play around with these parameters in this tool to our heart's content. We can look at graphs, pretty fancy colored graphs. They're really just nothing more than graphical representations of our estimates, but they're great for putting in front of project managers and steering committees for estimates. With these two circular graphs down here, I've attempted to try and put some milestone dates of when each of the different phases within the test cycle might start. And as you can see, we've got a time for design, a time for development, our first execution cycle, our subsequent execution cycles, when it's going to be ready, when it's going to be complete. And the same sort of graph for a cost breakdown on using our cost estimates and parameters as per the tool. So it's all interactive, it's all real time, so change a parameter here and things will work differently and they will show differently. And maybe a small change, such as the one I'm increasing in right here and lowering the complexity. I may choose to execute all of my test cases in every cycle. And we can see straight away what that does to our estimate of execution. In this case, of course, because our incident fix rate is so low, it doesn't change our date. But if we say we can fix 20 defects a day, and we see very quickly that the main effort now is back on our test execution. And if we increase our number of test analysts, we might get the job done faster. So I guess as I said earlier on, the main objective with demonstrating this tool is really just to, I guess, query whether there might still be a need of such a tool as this. Because coupled with a tool like from Inflectra and Test, we could create a software bridge, so you could take the output from this estimation tool and create a test project within Test to these parameters. It would obviously pre-populate it with some dummy data, like your test requirements and your test cases might be just test case number 1, number 2, number 3, and test analyst number 1, number 2, number 3. But it could at least set up an infrastructure within Test based on the parameters that you enter in this tool. Conversely, you may have an older test project that you've got that if we could create, again, a software bridge or an API into this tool, we could take the parameters from an existing Test project and create an estimate for a new project using that Test project as a base, and which you could then manipulate the parameters as I've done here and create an estimate for your new project. Okay, I'm just going to stop sharing my screen and put yourself back to my smiling face. Apologies for the phone call in the middle. These things happen. One of those interruptions that prevent you from doing 100% productivity all day, every day. Anyway, I hope that has been a little bit of an expose. If you would like to ask me any questions, more than happy to take questions at Geoff, Geoff, at nztester, so that's nztester.co.nz, and I'm sure that contact information will also be on the InflectraCon webpage. Thanks very much for listening. There will be a Q&A session live. Just my luck, it'll be in the middle of the night down here at the bottom end of the planet. But hey, I'll be up, and if you need to ask any questions around the tool, or indeed any questions around test management that you might have, only too happy to share my experience. Thank you for listening. Have a great conference. I know it's virtual. Would love to have been there in person. But we all know that this world is a little bit of a different place these days than it has been in previous years. So keep well, stay safe, and yes, please contact me if you have any questions. Thank you so much for listening.